Hey, what's up guys? Welcome back to Fact Loop. Today, we're diving deep into the world of programming languages, specifically compilers and interpreters. By the end of this video, you'll know all about their differences, how they work, their history, and much more. So, let's get started. Alright, so first things first, what exactly are compilers and interpreters? Both are tools that translate code from a high-level programming language, like Python or C++, into a language the computer can understand, usually machine code or bytecode. But they do this in different ways. A compiler takes the entire program's source code and converts it into machine code in one go. The result is a standalone executable file that can be run without the need for the original source code. An interpreter, on the other hand, takes your code and translates it line by line, executing each line as it goes. So, there's no separate executable file. The interpreter needs to be present every time you run the program. Let's take a quick trip down memory lane and talk about how these tools came to be. The first compiler was developed in the 1950s by a brilliant woman named Grace Hopper for the A0 system. It was a groundbreaking invention that allowed programmers to write code in a more human-friendly language, which was then translated into machine code. Interpreters have been around for just as long. Early examples include the first versions of languages like Lisp and BASIC, which were designed to be more interactive and user-friendly, making interpreters an obvious choice. Section 3. How they work. Now that we know what they are, let's dig into how they actually work. Compiler workflow. A compiler goes through several stages. First, it parses the code into a data structure called an abstract syntax tree, or AST. Then it checks for errors and optimizes the code before finally generating the machine code or bytecode. The result is a fast, efficient, executable file. Interpreter workflow. An interpreter skips the compilation phase and goes straight to execution. It reads each line of code, converts it to an intermediate form, and executes it immediately. This makes development faster, as you can see results right away. But the downside is that interpreted code usually runs slower. Section 4. Differences and use cases. So, when should you use a compiler, and when should you use an interpreter? Speed-compiled languages like C++ or Rust are generally faster because the code is optimized before it's executed. Flexibility. Interpreted languages like Python or JavaScript are more flexible and easier to debug, making them perfect for rapid development and scripting. Portability. Compiled code is often platform-dependent, meaning the executable might not work on different operating systems without modification. Interpreted languages are usually more portable, as long as the interpreter is available for the target platform. Section 5. Pros and cons. Before we wrap up, let's quickly go over the pros and cons of both compilers and interpreters. Compilers, pros: faster execution, optimized code, no need for source code at runtime. Cons: longer development cycle, platform dependency. Interpreters: pros: easier to debug, quicker development, platform independence. Cons: slower execution, requires source code at runtime. Outro. So there you have it. Compilers and interpreters are both essential tools in the world of programming, each with their own strengths and weaknesses. Whether you're looking to build fast, efficient software or develop something quickly and flexibly, knowing when to use a compiler or interpreter can make all the difference. If you found this video helpful, make sure to give it a thumbs up, and don't forget to subscribe for more tech content. Drop a comment below if you have any questions, and I'll see you in the next one. Take care.